Hey guys, it's Afiq, and today in this video, I'm going to tell you a great physics textbook that you should read to get a start on learning theoretical physics for yourself. Now, I'm not a professional theoretical physicist, but I did do it at uni, and I've been self-studying theoretical physics ever since I graduated for around 4 years now. So take my advice with a pinch of salt. All I can tell you is my personal experiences with things and hope that I can say it with enough conviction that you might find it convincing. So, honestly, I'm going to tell you straight up that you should read as many physics textbooks as possible. When you read a single textbook, you will have questions unanswered. And the whole point of reading something different is that you can resolve these unanswered questions from a different text. When doing science, you should confirm your suspicions by reading a different source, or better yet, conducting an experiment yourself, even though that's probably impractical when you're dealing with high-energy physics. If you're serious about self-studying physics, you're also going to have to Google questions that you can't do yourself, whether they're algebraic or physical, on Stack Exchange. And I can guarantee you'll never find these kinds of resolutions to your questions in a textbook. And it's even unlikely that you'll find solutions to exercises in textbooks, even though I believe that authors should put them in there. I also feel that another great source of learning physics is through university and lecture notes online. But these university and lecture notes tend to be in slightly less depth and are simply more sparse in terms of words and are more concise. They're designed to efficiently pack stuff into your brain before an exam rather than actually learn about the motivations of why things are there. One exception, though, I feel like is a great resource are David Tong's notes on pretty much any field of theoretical physics that he's written. With that in mind, this is a textbook that I think you should read if you want to get a start on learning advanced theoretical physics by yourself. It's called Quantum Field Theory and the Standard Model by Matthew Schwartz. Now, why do I think this textbook is great? Well, few reasons. The first thing is the subject matter. So it's about QFT. QFT is quantum field theory and is probably the most important field of theoretical physics that you'll ever learn, and it's currently the best mathematical language we have for explaining our universe. It forms the basis of the Standard Model, quantum electrodynamics, and so much more. So if you're serious about trying to learn theoretical physics, QFT is a great place to start, given that you know your quantum mechanics and your classical mechanics quite well already. The next reason why I recommend this textbook is because it's mathematically in-depth. And I honestly think it's no point in studying theoretical physics by yourself if you want to be serious about it, unless you're willing to learn the math and do problems. So a textbook that mathematically is in-depth as possible is great, and it's not something to be feared. Now, the most important reason why I think this textbook is great is that it has worked calculations. And by worked calculations, I mean the author gives you explicit examples about how to calculate things. For example, the scattering amplitudes in different physical theories. So let me just give you an example right here. For example, in this section, there are pages on how to explicitly calculate the cross-section of an electron and a positron scattering into a muon and an anti-muon explicitly. And the author actually tells you the explicit algebra into how to do it. And I think this is really important because the only way you're going to understand something is if you can actually do the explicit calculations yourself. Now I'm just going to come up with more examples. For example, he tells you explicitly how to use generating functionals to calculate certain amplitudes of interest here. He explicitly tells you line by line in fairly simple terms and with a lot of words how to renormalize something, which honestly it's surprising how difficult it is to come up to get those explicit calculations online. It is just an absolute mess in terms of where to look. So this is the most important thing about this book. It tells you really explicit calculations, and honestly this book has helped me so much during my master's course. Another reason why this book is great is that it gives you historical context on why and where the previous models failed and where quantum mechanics or QED has come in to fix these models. So in terms of content, the first chapter covers field theory, which is really important just to understand the maths of functions of spaces and how you can turn them into objects and quantize them to get different energy levels. This is really important. The next chapter after that is QED, which is everything to do with electrons, photons, and how those two things interact, which is a really beautiful theory, and it's covered in great depth. And then the chapter after that is renormalization and other advanced topics, which again is extremely interesting, and again with explicit calculations. So yeah, that is honestly a book recommendation that I think is great. So I hope you enjoyed this video, and if you decide to get the book, let me know.